All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're saying here we have some hollow column in between two bearing plates, one at the bottom, one at the top. That column has an outer diameter of 150 millimeters and an inner diameter of 120. So our solid lines is the outer, our dashed ones are that inner diameter. The load imposed by our column by the timber beam is 150 kilonewtons. So there's something from that beam pushing down on our bearing plate and then transferring to the column, 150 kilonewtons. We want to figure out if our circular steel bearing plates transfer this load to the column and then on to the ground. Let's get what's our bearing stress at the surface between the column and the bearing plates, really where those two bearing plates touch the column. And then part B, what's the required diameter of our lower bearing plate if the average bearing stress between the plate and the ground can't go above 3.25 megapascals? So let's come in and try to tackle that. The first thing, let's look at part A in here. So if I'm dealing with part A, I know I'm looking for what's the bearing stress. That's just a normal stress for us. It's just a compressive one typically. I need a force divided by an area. That force should be 150 kilonewtons. So I need my area in here. So this is my cross-sectional area of the pipe. A pipe should be, well, I have diameter. So let's do pi d squared over 4. If I have inner and outer, I can combine those together and have a pi fourths times my outer diameter squared, 150 squared, minus my inner diameter squared, 120 squared. Really, we've written this in one step, pi fourths times my outer diameter squared minus pi fourths times my inner diameter squared. This is going to get me, my total area is 6362 millimeters squared, with a little bit of rounding in there. But if I know that, I can actually go on and get my bearing stress for this. My sigma bearing on those plates onto the pipe or the pipe onto the plate should be force divided by area. I just got that area of the pipe, so this would just be 150. But there's one quick thing we want to check. Remember, we talked through, we do our units for these. We want to work with newtons and millimeters for our SI units. So I don't want to do 150 kilonewtons. Let's convert that into newtons. So 150,000 newtons divided by my millimeters squared, 6362 millimeters squared. When in doubt in SI, always do newtons per square millimeters. We could do this otherwise, or other ways. This will always get us a megapascals coming out. If we don't have to juggle units in SI, this is the one time where SI units are kind of weird to get from newtons and millimeters squared to pascals. Just stick with newtons, millimeters. We get megapascals every time. So my bearing stress, sigma bearing, is going to work out to be 23.6 megapascals, MPa. And that'd be my answer to part A. From there, I can plug on and say, what about part B? The required diameter of the lower bearing plate, so down at the bottom, if the average bearing stress between the plate and the ground can't go above 3.25 megapascals. So we'll go in and say, well, now I'm looking at part B on this, and I'm saying my sigma bearing here is going to get me to 3.25 megapascals, or that's my newtons per millimeter squared. But I know pushing down on this, I already have a stress of 100, or my force is 150,000 newtons. That 150 kilonewtons just transfers straight through everything. So this is 150,000. So again, we'll be in newtons here, divided by my area of the plate, divided by a plate. And I can solve that for my area of the plate. I should get millimeters squared coming out, because if I have newtons here, Those are going to cancel. I'll be left with millimeters squared. And I should get my area of the plate. A plate is 46,154. 154 millimeters squared. Which from there I can come in. I'm not asked for the area of the plate. I'm asked for what's the diameter of that lower plate. If I have area, I can get there though. My area of this plate, a plate, should be pi times the diameter of the plate squared over 4. Just again using pi d squared over 4. Or I could do area as pi r squared and then multiply by 2. It gets me that same end result to get to a diameter in here. This is giving us, I just found that area, 46,154 is pi times the diameter squared over 2. Pi d squared, not over 2, over 4. So multiply by 4, divide by pi, take the square root, and we want the positive root in here. Will give me that the diameter of this plate has to be at least 242 millimeters. Otherwise, the stress is going to be too big, and probably the ground is going to give out underneath it, which causes things to collapse. And we don't want that in our buildings. But hopefully this is a useful video for us. If it was, stick around, watch more videos, hit our like and subscribe buttons. Let's get you in A with JJ.